Okay, welcome everyone. Okay, we have Ahmad, we have Ali, we have Rayana, we have another Ali. Welcome everyone. It's so great to see you again. Alright, so let's get started. So, version control, Git and GitHub. So, you guys probably heard about GitHub already. I would love to see if any of you don't know it already. So, type in the chat if you already know GitHub. Let's see how many people know about Git or GitHub. Taha, Dima Darwish, Ala. Welcome everyone.
Hello everyone, who doesn't know GitHub here?
Okay, a little bit. Yes, yes, yes. I know. I used to do all my uni project there. I know it, but I don't know how to use it. Kind of familiar with it. This is good. I can see that some of you have some background with Git and GitHub. Today we will just be going through some basics so you will be able to deploy your project and send it to us. Okay, so we will I want you guys to get ready for some cool content because today I'll be teaching you something that's really important for pretty much any software engineer, any AI engineer, or anyone that's connected to code or uh, tech in general, right? Because you will definitely be sharing your code with other people. You will be definitely submitting a lot of projects throughout your career, and Git and GitHub is basically the solution for that, right? So before I dive into the topic, I want to introduce myself to you guys. So I'm the founder of Sprint OS. Uh, I'm really passionate about tech solutions, creating community experiences, hosting events mostly. I come from a software engineering background, from mostly from the Near East University. I enjoy working with intersection and coding and event planning. This is some of you might not know this, but I already hosted a bunch of events before. Some of you might attended with me before as well. Uh, and outside of work, I really love ice cream. So enough talking about me. Let's talking about some version control and dive into it straight. So today we'll be covering version control, what the purpose and benefits of it is, and then I will show you a tool for version control, which is Git, and the user interface for it, which is GitHub, and we'll cover some overview and uh, integrations for their key features in between. And then I will teach you the workflow for GitHub, how to deploy your projects, or basically anything, any code that you want to show to someone or submit, right? And lastly, we're going to talk about some group project submission techniques as well. So version control is a system that records changes to files over time, allowing you to revert to specific versions. So all in all, maybe one day you are working on this code, right? And you make a mistake and you no longer know how to fix it, right? Even with ChatGPT or some AI tool, you don't really know how to fix it back or restore it to the state where it was nice, right? Or it was like, let's say, ready to go. So with version control, you can go back to, oh wait, is my microphone off? One second. Oh, you can hear me. Okay. Sorry, for a sec I thought. Tamam, tamam. Okay. I'm glad. So let's go back to where we stopped. So for version control,
Your mic is good, Hassan.
tamam, thank you so much, Sarah. So for version control, maybe you are working on this code. There was this state where it was fully working, but you broke that rule where you're not supposed to touch a code that's working, right? So you just go mess with it or try to update it or add a feature, but boom, you destroyed the entire code base and it's no longer functioning. So with version control, you can track the history of changes and revert back to the version where it was actually working. You can facilitate collaboration. For example, if you are working with people, you can work on one GitHub repo together, add the code together, and divide the work in between you. This is very important for your group project. You can improve your code quality. For example, you already have a good working code base, but you want to make it faster or more efficient. So you can improve the quality by something that's called contributions, right? Maybe you can post it somewhere and you wait for people to contribute and show you some things that you can do to your code to improve it, and you can merge it with your own code base. A lot of companies out there actually do this. There is this company called Udo. Uh, they have their sources and code base as an open source out there on GitHub, and a lot of software engineers around the world try to find bugs or find some things that they can improve in the code, and they send a request to Odoo themselves over GitHub to change some lines of code or even add new files, right? And once they merge it, it becomes the official version. That is what that was posted on their company website in the beginning. Lastly, we can prevent data loss. For example, if something happened and you lost some data, you can revert back, as I said, and just go back to the state where everything was just fine. So in short words, this session will make you powerful at VC, right? So now you know a little about version control, and I will make sure to help you do all of this and apply all of this using some tools, right? So why version control? As I told you, we try to revert back to good code or contribute with others, collaborate with others. For example, if I'm working with my friend on a project, we can divide the work between us and push the code to one mother repository, not a local repository, and a remote repository online where everyone will be sharing their code and everyone will be able to have the most updated version of the code instead of, for example, opening my Gmail and sending my code whenever I change it, and they will have to download it and no. GitHub is like a solution for that, so the most updated code will be out there remotely, and whenever someone tries to update their code on the remote repository or directory, they will have to pull the updated code and check if they will have to change anything before they push back their code. So, what is Git? Git is a distributed version control system created by Linus Torvalds. It's a system to apply version control. Is Git the only thing out there? No. We have a lot of other systems, but Git is the most widely known used around the world. It tracks changes locally. So if you changed something on your local code, it will be apparent. You can create branches. For example, if you are working on a project with someone, you can create a branch, for example, that says feature number 3. Okay, so you will just be concerned with that specific feature, not the overall tree of code. So let's say you have a website, for example, that has, for example, 5 pages. Instead of editing the entire 5 pages, when you are changing just one page, you can create a branch, edit only that page, and only change that page instead of changing the entire code and posting the code every time you are updating or like updating the entire code. You can just like update one root or one, let's say, sub tree of that tree, right? And you can merge it with the original code. It works offline and syncs when online. So that's something really good. If you don't have that good of a Wi-Fi, or if you are outside and you don't have Wi-Fi, you can work on your stuff, and whenever you are online, it will just synchronize. Okay, so GitHub is basically the user interface of Git, right? So it's a web-based platform for version control and collaboration. Are they the same thing? No. but GitHub uses Git technology to see what's actually going on in Git visually, right? So it's web-based, and there is, I think, there is an application for it, like a software that you can download even. But I personally use the website because it's fast, it's simpler. You can just go through it really quick and share the link as well. I don't know, like I just prefer the web-based version, but you can definitely download what's called the software itself. You can store and manage your code repositories and share your code much in a much easier format, and you can track your change using Git, as I said. So we're using Git technology. We're collaborating on projects in real time, and we are hosting open source or private projects. So if you are, for example, trying to get hired in this company, company X, for example, they might ask you to send them your GitHub profile, and then they will be able to check your projects, check your code bases, and see if you're actually a competent for the role that they are offering. So some key features we have here are pull requests, issues, actions, and pages. So we will show you how to create a pull request for your group project, because that's basically how you will be uploading your code. So far, do you guys have any questions? I requested to be assigned to a group with a friend. Can I change groups? Of course, Jibran. Please feel free to contact me or contact Sarah, and we will make sure to help out. I was not assigned to the group I requested. There is no problem with that. Like we had a bunch of people applying in the form, so there was like some sort of confusion when we were trying to add the people, especially that some people requested, they submitted the form multiple times. So yeah, it was possible for something like that to happen. Okay, Ali Kawar is asking, Git is the same as GitHub? Not really. GitHub is a platform that uses Git technology. So Git is let's say, it's the functionality. GitHub is the user interface for it. I hope it makes sense in a way. So do you guys have any other questions before we continue? By the way, guys, you can see my screen properly, right? Wait. Ta, ta, ta. Yeah, okay, everything seems fine. Tamam. So let's continue. Okay. So before we continue, I would love to ask a question. So you've been seeing this Pokemon a lot in almost every slide. So who is that Pokemon? If you guys understand this reference, let's see if you can type it in the chat box. Your screen is good. Yeah. So do you guys recognize this Pokemon from the Pokemon series? Squirrel. Yes, that's right, Muhammad. All right. So moving on. Let's talk a little about the workflow. Like, okay, Hassan, you've been telling us about GitHub, you've been telling us about Git, but how do we use them, right? So, you need to understand that we have like a set of commands, right? Okay, yeah, so we have a set of commands that will move your code from, let's say, okay, this is your code, it's in the origin. What is the origin? Basically, the remote view. Wait, let me edit it. Wait. So yeah, you are in the origin. You, one second. Let me just open my other account so I can show you. Tamam. So let's say this is your code. You are on a local repository. Yeah, like basically your PC or laptop or whatever device you're using. you use a function called get add or an instruction. You put it in the staging area. Now we are saying this code is staged and it's about to be switched or like transferred from local to origin, or basically the remote repository like GitHub, right? So we use get add to move it to the staging area. After we make sure that it's ready to go, we use get commit and we push it to the origin, right? So we moved from the local to the origin. So we basically uploaded our code online. What if we want to go back from origin to local? We will use something called get pull, and it will go back. It will switch and show whatever you had in the origin, if it was updated, and restore it back to your PC. So for example, if your friend was in the origin area and they wanted to do a modification, for example, I don't want this, I want to delete it, and you wanted to edit the code or like create a new file or edit a new file, you can't do that until you pull, you go back to the local and you see, okay, there was something deleted. So now I need to make sure that everything is compatible and stage it and commit it. Simple, right? So this is a cheat sheet for all the commands that you can do in GitHub, or like the most important ones, let's say. So you can, I will send this on the WhatsApp group, and you can go through all of them and learn uh, about them, how to use them, and so on. I don't know most of them, but I will say that this get init, get clone, add, commit, and push are the most important ones. And also you have pull, of course. For the other ones, I'm pretty sure they are really useful, but you might not need them like when you are working. But the ones that I noted, you will be definitely using them in almost every project. So, so you need to push your code to GitHub. You need to create a pull request. For example, if you are trying to propose or merge a set of changes from one branch into another. And you need to be solving conflicts if there was something that you want to
Hassan,
edit in your
please
code.
repeat the explanation because the attendees are asking about it.
This one, wait, the staging one. Wait, I want to know how to fetch project from GitHub, from GitHub to V code. Sure, sure. I will show you that right now. The command from origin to local is get pull. But so to push your code, you'll be using get add, then get commit message, then get push to whatever you are pushing to. You are pushing to. Okay. If you are going back from online to offline, let's say, if I want to say it in the most easy terms, you'll be using get pull for remote or online to local. Okay, I hope it makes sense and it answers your question. So enough talking too much about all of this. Let me show you how to actually do it. Okay, let's open VS Code. Let's create some new folder. So I am in my desktop and I want to create, let's say, a new file, a new directory. Wait, I trust the others. Okay, so I'm creating a new folder. Let's call it, wait, so new folder. Okay, I will create it outside. So here, let's call it Bootcamp. تمام. Bootcamp dash get. Okay, now we have it in our VS Code. If the font is too small, you can let me know. Okay, so you can locate it here. I will create a new file. Let's call it, let's say app.py. I will write some Python script. Let's say print hello world. Very simple, very straight to the point. right? Now I will save it. It's saved. Can you guys see my VS Code? Is it clear? Okay, just let me know if there is anything. Okay, so as you can see here, I created a directory, I created a file. Now I have it here on my laptop, but I want to upload it online, right? So I'm not just gonna go and let's say zip the file or add it to a RAR file and send it. That does not make sense at all, and it will take a lot of time. So I will go to the GitHub page, GitHub website, and you can maybe create an account and so on, and then click here on new. This basically creates a new repository. You can give it a name. For example, I will call it get class. I will make sure that it's public. You can add a readme file if you want to. I suggest that you keep the other settings as default, and then you can create a repository by clicking on create repository. Now, GitHub will give you some instructions to actually deploy your code. So first it says get init, get add, get commit, branch, remote add, and so on. But okay, where am I supposed to write this, right? Now, uh, I will not go through the command. You can use command prompt. This, but I'm pretty sure not all of you are using Windows, so you can feel free to use VS Code by creating a new terminal. See, I created a new terminal here. I will be writing my code or instructions straight here. So get init. You need to make sure that you are in the correct in the correct directory. So I will move into bootcamp dash get and initialize get by get init. After that, I want to add my file. So get add app.py. You can either write get add app.py, or if you have multiple files, you can write get add, then dot. This will add all the files in that repository. Then I will commit. What does commit mean? So as you can see here, we were in the local, we committed. Now we are in the staging area, right? And now I will commit to push my code. So I'm going to commit dash m, and then whatever message. So let's say I added app.py. One file change, one insertion, but okay, now I committed it, but it's still not there online. So what am I supposed to do? I need to follow the other instructions. Then create a branch that has the name. You can feel free to copy the link from the GitHub website.
Hassan, they don't see the stream anymore.
How come? Okay. I know what happened. Okay. This is because of the shortcut.
Hassan, they don't see the stream anymore.
Okay. It's there. Okay, done. I fixed it. Okay, guys. So I will repeat starting from when we started. Wait. So let me just Bitcoin slash get. So I'll delete the get file and I will start over. Okay. So we are here. Can you guys see my screen now? Can you guys see my screen? Okay, you can see my screen. Perfect. So we saved the file. We opened a terminal and we're gonna go to the Git website and basically copy the instructions one by one. So get init, but not in the desktop. You need to be inside of that directory. So cd bootcamp dash get. Okay, now get init. This initializes a Git repository inside of my local device. After that, I will add the files. So get add dot, which adds all the files in my directory. Then commit them. So the get commit slash m. Then some comment. For example, added app.py. One file changed, one insertion, created mod for app.py. Perfect. Now I need to create a branch by writing get branch slash capital M main. So now I created a branch. How do I check what branch I am in? I will write get branch and it will say main. Perfect. Now everything seems really good. But to link get to GitHub, you need to add a remote origin by writing get remote add origin, then the link of your repository and click enter. Now my local repository is linked to the online repository, and then I have one final file that says one final command that says get push dash u the user and then origin to main. So we're pushing to the origin our main branch. So we created a main branch, we added the files to it, and now we want to add, we want to link it to the origin and push to it. So when I click enter, it will take a while to process everything. It will write objects 100%, enumerate objects, and we're done. Now when I refresh this, you can see that I created a GitHub repository that has the file app.py. Perfect. Now, let's say I want to edit this file. I want to update it. So I will add print 5 plus 5 and save. Locally, okay, locally, I can see that my app.py is updated. But when I refresh my GitHub repo and open the file, it's not there. It's not really there. I just see print hello world. So my local repository got updated, but the remote one was not updated yet. How do I fix this? So remember how I told you we have some commands to fix this? So we already initialized our get. Our get is ready to go. But we want to add this file to make sure that uh, it's the most latest one. So we will be using get add dot or app.py, doesn't matter. Now I added the file, but which version of the file? The old one or the new one? The new one, right? Why? Because after I save it and after I use the instructions, we are just referring to the local one, not the online one. So I added it, get commit, and now I will change my message. I will say I updated app.py. These messages are really useful for whoever is your manager, for example, who wants to see what you are committing to the online version. So here you can say, you can see one file changed, 3 insertions, and 1 deletion. Perfect. Now, one final thing I have to do is get push u origin main again, and I click enter. After I click enter, I can go and refresh my page, and as you can see here, print 5 plus 5 is here. So right now I'm connecting both the online repository or directory of the code with the offline version. Do you guys have any questions so far? Can he increase the volume of his voice? Sure. I will try to check my OBS. Okay. It's the maximum, but I will try to keep the microphone close to me. Where does the message show? So I will write the command for you again. Get commit slash, not slash, dash m, double quotes. Hi, this is a message. So this would be your instruction. The voice is fine. Can we bring a web from GitHub to VS Code? Exactly. This is what I will show you in a bit. So if you have any questions, feel free to say them. Can you please type them here? I will send you the instructions again, Hassan. You can feel free to go through them. I will not send only the instruction. I will send the cheat sheet that I have in my PowerPoint, so you can refer to it if you want the instructions themselves. I don't care about you guys memorizing the instructions right now. I just want you to understand what's actually going on. Okay? Perfect. Uh, so we should work on separate branches. No, if more than one person is working on the same file at the same time to be able to merge our work. You can feel free to create multiple branches for each member. Okay, but that's a little, let's say, advanced for people that are new for to Git. So you can feel free to work on the Git on the main branch only and keep pushing and pulling from it. So let me show you how to actually do that. So I will edit this file on the online version. So I will add another print that says uh, 10, then some comma, and then hi, I guess. So this new Python line, okay? And I will comment the changes on the online version of the Git repository. Now I updated it, and the comment is here. But if I go back to VS Code, my VS Code is not the same as the one on GitHub, right? So how do I change that? How do I get the same line that was on the online version on my GitHub? So there is this thing that I told you earlier, which is get pull. When I click on get pull, I get my file updated locally as well. Now I notice that there is some error here, so I can fix it locally and push it back again. How? So let me clear the terminal. Get add dot get commit. I fixed a syntax error, and now I will push it again to the remote repository. Once I click enter, it will do its magic and push it to the online version. Now when I refresh the GitHub page, as you can see, it's fixed, and you can refer back to the history here and see all the commits that happened. I fixed a syntax error, update app.py, I updated app.py, added app.py. Perfect. So now you have a basic understanding of how to push and pull code. So moving on with the session, I need to show you just one last thing. So now, as you know, you need to work on a project and upload it and basically send it to us, right? So how do you do that with GitHub? So Code with Sarah created a repository that has the name AI, not slash, sorry, n hyphen summer, n hyphen sprint, n hyphen bootcamp, right? And as you can see here, this repository has a readme file only, right? And it has all the instructions that you need. But I will show you that step by step. So after you go to this page, you can click on the fork button in the top right. So here, I will click on it. I clicked on fork, and I got this page that says a fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project. So I'm not trying to change Sarah's project. I'm trying to change a copy of it. So required fields are marked with an asterisk. No available destinations to fork this repository. So I already created a fork. There will be some button to create a fork or so. I already created one here, as you can see. I have the same file, but I want to change something in my version and send it to Sarah, so she will be able to see it, and if she liked it, she will be merging it with her own code base, essentially. I hope it makes sense. So basically, I'm trying to update her code or her file and give it something from my version that is the copy. Okay, so let me clone into this. Or actually, let me start over so I can show you how to do it from scratch. So delete this repository. I have read and understood this. Let me show you from scratch so you guys wouldn't get lost. So I deleted my version of it, the copy. Tamam. This is my GitHub account if you want to follow it, by the way. Anyways, so I'm here again. I click on fork. Now I created the fork. Now it will ask you to put the name. Just keep it as is. And you can copy the branch that you want to change. For example, maybe Sarah created multiple branches, each one for each branch or feature, let's say. But here we will just be doing the main branch to keep it as simple as possible. So I will create a fork, and now I have a local repository or a copy of her version. Right. Now, the second step from the page, let me show you. So the second step here is to clone it. So here we will clone that page that Sarah have, but you will be putting your version of the code. So when you are filling the link, you will put your GitHub name. So here my name is Hassan slash not slash dash Kokani. So I will go to Visual Studio Code. I will go back to the desktop. CD. Okay, so I'm at desktop right now. Clear. I'm at desktop. I want to clone that repository. So get clone is another instruction for that. Then you can place the link and put your username. So here my username is Hassan in hyphen Shkukani. Now when I click enter, wait, too many arguments. Oh, okay, I wrote get clone twice. So wait 1 second. Clear. Okay. So write your username as I said, Hassan Shukani slash AI Summer Sprint Bootcamp. Cloning into the thingy. So I cloned into it, and now you can see in my desktop I have a new file. This file has whatever Sarah uploaded. So to upload your project, you need to create a new directory that says, for example, group number 3, and add your code to it. For example, I want to add my app.py again, print hello world. Perfect, right? Now I save the file, and it will not be affected on her repository, right? Because this is my version of it. So the third step, as you can see here, is to add the file, git add. No, wait. I need to go back to the repository. So CDI Summer Spent Bootcamp. Now git add all the files. So this will add the new version, the new files that I added to the repository. And now, after I add, I need to commit the group project name. Right. So you can write clear get commit and put the comment as something that will help us understand which group project you are referring to. So I will say here group number 3, and my name is, my group team name is Team Delta, for example. So make sure to include this in your message so you will understand which group you are in. And I committed. One file changed, one insertion. So I inserted a new file. Now git push origin main. So here we didn't add dash u because I'm not the user that has the permission to actually to push to that version of the code or that repository. She owns the page, I don't own it. So I'm trying to suggest something to it. So I will be pushing directly to it. So get push origin main. Okay, very good. Now I will go to my version. refresh the page, like the copy again. Okay, so this branch is one commit ahead of code with Sarah. So you need to click on create a pull request. So you need to contribute, open pull request, add a title, the message basically, and click on create a pull request. Very good. Now we are good to go. By now, I submitted my group project work. Basically, you just need to do this. Whenever you are done with your project, you need to create a pull request and fork into the repository and put your code and send a request. Sarah will open her GitHub account and check your file. If everything seems good, you are accepted to go into the finalists, and we will consider you for the competition when we are trying to announce the winners. If it didn't work for whatever reason, or if your project was not competent enough, or if there was any error, it was not working, for example, then unfortunately we will not be forking your code into the project, into the repository. Perfect. Now I need to request from Sarah to open her GitHub account and accept, so we can show you guys. So Sarah, can you please open your screen and show us your merge to my request, or show them basically what you see from your end?
Yeah, sure. Just give me a sec.
Perfect. So guys, do you have any questions so far? Hussein, no problem. You can definitely feel free to use your office hours for this, or essentially, you can even contact me. I can send my LinkedIn after this, and you can feel free to ask me whatever questions, and I will send you all the commands that you will be needing. So do you guys have any
We
other
will be
questions?
repeat- we will be repeating this, sharing with you a very detailed guide on how to do that, and you will have to re-attend this session to follow by the instructions. Uh, Please make sure to submit in this very exact explanation that we went over with you guys. Okay. This is how you can submit. You cannot go and create your own GitHub repository and just send us that. No, that is not allowed. Please make sure to submit in this way. This way, you ensure you are being authentic and we're actually seeing your work and everything, and that we actually received it. And this is an important skill to learn. So, usually, when you're working in companies or anything, you would be doing those. So, it's extremely important. Okay, I will be sharing my screen. This is what it looks like from my side, right? All what I have to click on is confirm merge, and that's it. Alright? Definitely make sure to rewatch this video and everything, and we will be having office hours with you guys to guide you as in how to submit that. Now, regarding the project submission rules, you can choose maybe one member can be doing that for all of the team, right? Which is the preferable option. Only one member does that and submits, okay? But of course, we will be taking from you a Google Doc written on it what everyone worked on, the tasks, allocation, etc., everything. We will be sending details today once the group allocation is finalized. We are finalized, still waiting on very few members. Some members did not accept the invite that we sent to them on WhatsApp. Please accept the invite. Hassan Mahmoud is saying, but you will take our projects this way. How will I be taking your project if this is something that you guys worked on? It will be showing on the organization of Code with Sarah on the AI Bootcamp Summer Sprint Bootcamp, all right? Which just basically proves that you actually attended the bootcamp. and participated in the project and built this project as part of the bootcamp. All right, and you will be getting a certificate for that as well. Tariq is mentioning, so one team member forks the repo and clones it, and then yeah, you can add that. You can do that. How we give you our projects using GitHub? We just follow the commands that you show to us. I don't understand your question, sir. We just went over it during the session right now on how can you actually submit those. Okay, so you are participating in this bootcamp to be introduced into the AI field and to dive into several AI fields and basically get your hands dirty with several AI fields. So, the purpose of this bootcamp is to introduce you to several AI fields, and you can choose which of those you'd like to build your project in. Okay, we won't be giving a certificate for those that don't participate in the project. This is extremely important. Unfortunately, we cannot give a certificate for anyone that doesn't participate in the project because this bootcamp is hands-on, meaning you wouldn't be getting just sessions and all theoretical information. No, you will be applying, you will be building something as an outcome from this bootcamp. All right? And if anyone has any further questions, please make sure to ask us here right now because we are unable to get back to everyone that is reaching out privately and such. Either ask us here or on the group project that you're in or in the Q&A group. Okay, I believe we don't have any further questions. Right now, we will close in 10 minutes and then we'll start the new session, and I will find my WhatsApp flooded with questions. Okay, I believe everything is clear then. Let's hope I don't find my WhatsApp flooded with questions now. Alright, so please, guys, join us in 10 minutes. Take a 10-minute break and then join the next session. You don't want to miss that. It's an extremely interesting session. It's starting in 10 minutes, okay? So, see you there. Does a group need to be more? Yes, Jubran, we already mentioned that. The allowed number for people in a group is 4, 5, or 6, nothing less and nothing more. Okay? You can be up to 4 people, 5 people, or 6. No, you cannot be 2 people, Jubran. Okay, any further questions, you can stay in the stream and ask us. If not, then we'll see you in 10 minutes, guys. We will be starting the next LLM session. Is there anyone we can ask? Yes, this is why you have office hours. You have 2 office hours that you can use them, and you can ping us on the group that you are in. All right, we will start allocating, specifying the office hours times for each group alongside a detailed instruction and everything. Okay, so please be active and ensure you're collaborating and speaking on the WhatsApp groups, because if there is one team member that is not participating, not speaking, not collaborating with their friends, then unfortunately they will be moved and removed from the group. Okay, I believe there aren't any further questions. All right, then. See you in 8 minutes, guys, for the LLM session. I wanted to ask how to convert our codes to web pages. Why would you convert your code to a web page? You mean you would like to finish the AI related part, build the model and such, and deploy it in a website? Is that what you mean? Basically, have a final software outcome and all? Is that your question? Please specify your question. Okay, great. We will be having a session about that. Yes, we will be having a session about that, so don't worry. All right. Please focus on completing the AI part first, and then later on, we will be introducing you into that. All right. And today's session is going to be beneficial for you, by the way, so also make sure to attend it. Yes, it is required because we mentioned that the project consists of two parts, the AI part and the software development part. All right. So you can ask in your team who's familiar with web development. Maybe you guys want to do a mobile application or something. Depends. Maybe you'd like to do a Chrome extension. It all depends. All right.
Sure. Okay. Hello, everyone.
Today's webinar is about model serving, or to be exact, LLM serving. It's something not very familiar. Not everyone has worked with it. So we don't usually see it a lot, talked a lot about in webinars or in events, but it's something that has been developing since ChatGPT was out. We have a lot of frameworks. We had a lot of things we can talk about. We'll go a little bit over what is model serving and what us consumers can use to host our own models. Please confirm that you can see my screen. Okay, things like now. Okay, so I will be talking about what is model serving or LLM serving, why do we need it in the first place, some considerations we take when we want to host a model, like the hardware, the model, the parameters we use, and then we'll introduce some LLM serving frameworks. Finally, we'll go hands-on. Hopefully, I won't take long with the theoretical part. And we'll go to the more interesting actual implementations. So what is model serving? At its core, model serving is a process that addresses the challenge of making AI models accessible to the end user. Basically, it allows us to use the models after training. Research companies or the AI team at a company would go on to train a model until they're satisfied with the results. And then what? We need to use it. So how do we use it? Here comes model serving. What we do is we build a stack to serve the model to the users, either through APIs, web services, or even integrating it to the app itself. Like we can actually put the model itself inside an application on desktop or on iOS, on Android, etc. for the reason of generating new predictions on unseen data. To draw a simple analogy to businesses of all kinds, when they want to deliver AI capabilities to the customer, we use model serving as a part of the supply chain. So for example, Amazon and Netflix, they always recommend us stuff when we're searching new movies, new things to buy. These are actual models, AI models, hosted somewhere where the application or the website would use them to get the new predictions and recommend them to us. Also, banks use models to detect fraudulent transactions during online shopping, checkouts, or during, for example, transactions between banks. So like every other business, any manufacturer, any business, any company would like to have a very cost-effective supply chain, and like so, AI companies would like to utilize models in the most effective way. So they don't want to pay a lot to use these models. So in production environment, we usually want to decide what hardware do we want to use, how do we want to use them. For example, how many requests would we like to accept? What's the speed of generation, etc. So what we're saying is that the AI company would first train a model. It would then put its source code, its artifacts, everything from requirements to the services and endpoints into one box, into a black box, or if you would like to call it a bento. So it's just a box with everything related to the model. And then we would provide this model to the end user through an application or through an API. That was what we said. That's the summary of it. So more recently, large language models have exploded in popularity. They are fairly large models that can be adapted to many tasks. However, because of their size, not every company could train them. It is very costly. It could go up to hundreds or even millions of dollars. Some of these providers are like OpenAI, XAI, DeepSeek, Google. Like Google have Gemini, OpenAI have ChatGPT. For example, Alibaba has, I think, the Qwen models, and then Anthropic with the Sonnet and Opus. So we know that LLMs are very powerful and they might satisfy all our needs, our application needs. We can just call their provided API and get the results. So why do we need to serve our own models? Why go through that all that hassle of deciding on the hardware and then serving and then maintaining the stack? The answer comes as in the pricing may seem very low at the start. Like they would charge you about a few cents per token or even less than that. But that actually racks up very quickly. So for a couple of thousands of requests, you might reach up to maybe hundreds of dollars or even thousands of dollars, depending on what you're sending, depending on your application. And businesses in real life actually hardly ever use a single model, a single LLM to solve all their use cases. In real life scenarios, businesses prefer to use smaller and cheaper models as much as possible to then leverage LLMs for more complicated tasks because of their how costly they are. But as demand grows, they generally also want to host their own models to lower the costs even more. So that's the first point, which is cost efficiency at scale. We don't want to pay too much for what we're providing. We always want to be more efficient. The second, and one of the most important reasons, is data privacy. So some companies work with data that cannot be shared anywhere, that can't be uploaded to the internet, especially for providers like Google, Anthropic, etc. They would use this data to train their models later on. So we don't want to share this data. So handling sensitive and proprietary data is often a requirement for some companies, which obliges us to use in-house solutions to meet compliances like the European Union GDPR and the HIPAA. Lastly, sometimes we want a specific model for a very specific case. We would then do what is called fine-tuning. But some model providers don't allow us to fine-tune their models. And those who provide this capability, like OpenAI, they charge significantly more than what they make us pay for their original models. So OpenAI adds a 50% markup. So because of these three reasons, we might want to use our own stack. However, there's a catch here. Serving and maintaining a model, an LLM, is actually expensive too. So, for example, a small GPU, a server GPU like the A10 or T5 or T4, it's called, would cost around $6,000 or more, going up to $50,000 for H100 GPUs. That's a lot. That's a lot to pay forward. However, on the long run, you would usually save up a lot. So let's consider two scenarios. The first one, we want to create a proof of concept for an education sector. We're making our own company. We have a business model to provide, use LLMs to evaluate the students' grades or exams, and then provide a curated or personalized study plan for each student. So when we're working for this proof of concept, we can use OpenAI and Anthropic and etc. Because it speeds up the development a lot. We don't want to think about hosting our model. We don't want to pay this upfront cost of a few thousands of dollars just to host our model to use it. We can use OpenAI, etc. However, when our business goes live, we're now we're not just building a POC now, we're actually running a business. We want to think of being more cost effective. So there would we think, okay, now I want to host my own model. I want to be more cost effective. I want to pay less. And the other type would be, or the other scenario would be, let's take, for example, we're running a CRM or a customer relationship management company, which will provide sales for other companies and information like about other companies, about meetings, audio search, etc. So these are proprietary data. These are private data we can't share with everyone. So from the start here, we can't even use OpenAI. Otherwise, it would be fined, we would be in deep trouble. So here, from the start, we would go, okay, now if I'm going to build an application that uses AI inside my CRM framework, I would need to use a proprietary or a self-hosted model. So in model serving context, we're not thinking just of AI, of the algorithms, of the models. We're also thinking of business models. We're also thinking of costs, of engineering problems, of coding problems. So there are a few things that we need to consider whenever we're thinking about our own stack. First, scalability. Well, we won't always think about all of them at the same time. Sometimes security is more important than scalability. Sometimes latency is more important than scalability. Sometimes scalability is more important. Sometimes cost is more important. So it's always a case specific. So what do we consider? We consider scalability. So scalability is the ability to handle a few thousand or millions of requests efficiently while ensuring a consistent customer experience. We don't want a downtime for the users, or if there's a downtime, we want it to be very few minutes at max. Latency, we want to also make predictions as fast as we can, preferably in milliseconds. Versioning, when we're doing our own stack, we're hosting our own models. Okay, if a new better model comes up, we want to use it. So we install it, we download it, and now we start using it. And then it turns out that it has a problem. If you want to go back, we want to be able to go back quickly. We don't want to, okay, we're in a deep trouble now because we didn't version our system. So also versioning is important. Monitoring, we want to also monitor our model performance. How would we make sure that the latency is good, that we're serving enough requests? We want monitoring to track the model performance for any data drift and system health. For the deployment, we may want to make sure, this is very important, we want to make sure that we're using just enough hardware to host our requirements. So not every company needs a very large GPU like the H100 to serve their model. Sometimes you only need a few, for example, 3090s, which are consumer GPUs. For that use case, it might be enough, and it's much more cost effective, much more efficient than paying like four 3090s would be around $2K now, but an H100 costs you $50,000. So we're always thinking, what's the best hardware for our use case? What's just enough? We're looking for that point, just enough. Security, we also want any requests we send to the model to be protected and to be able to control and access the model with roles. So not anyone just can access our model. And finally, usually the most important factor is the cost to serve. Again, it affects a lot of other things. So we don't want to just, okay, we want to use our own model to host our own model. It should be also cost effective. It should help us pay less. So that's it for the theoretical part. Now I want to show you hands-on some frameworks. So the four most well-known frameworks to host our own models are llama.cpp, Olama, which is the second one, and then VLLM, and finally SGL, which is Structured Generation Language. The first two, llama.cpp and Olama, are consumer-grade frameworks. So they are meant for us. Like we don't have the best hardware, don't have enough money to pay for very large GPUs or server GPUs. So these were built for us. On the other hand, the LLM and the SGL were built for production grade, for companies. For example, SGL is used by XAI to run the Grok models. So that's it for the theoretical part. From now on, whatever I say will be written in these slides, but I won't go over them here. So first, let's try out llama.cpp. Llama.cpp is a project. It was started as a project by one person, and then it grew, and there are now many contributors. Llama.cpp does an amazing job by eliminating the need for a deep learning framework. Usually we use, for AI, we use PyTorch or TensorFlow or JAX. So it eliminates the need for deep learning framework and builds its own layers and algorithms from zero in C++. That's why it is capable of running at very fast speeds, even on consumer CPUs, not even GPUs. We don't always have GPUs, so that's one of the most important benefits. It can run on CPUs, and then it can run anywhere. It can run on phones, it can run on laptops, it can run on servers, it can run anywhere. And so how to use this? It is very easy to use. But I want to show you two things. So I prepared multiple use cases. For us, we will run first fill in the middle server to it's a coding assistant. I'll show it in a bit. But what's more interesting, honestly, is using it to host it on Android. It is available now on iOS, I think. So you can use it to build on Android. I want to show you this video. So this is llama.cpp used to run an LLM on a phone. So this is the video, a model is running, and then they would ask it a question. Of course, it won't have the performance of a laptop or a PC or a server, but it is available, and it is getting better and better. So yeah, we can see it is working, but very slow. Okay, so that's it. So what we're going to do now is run a model using llama.cpp and use it as a coding assistant in Visual Studio Code. For that, you can see the link here. It is available under GitHub. It's available on the GitHub here, VS Code extension for film completions. And also whatever commands I use during the presentation are available in a GitHub repo that I will provide the link to at the end of the presentation. So to install llama.cpp, you only need to use this command, winget install llama.cpp. It's very easy to install. And then to run a model, you need to run llama-server with the model name. Now, for these models, we usually use Hugging Face. Hugging Face is like the GitHub of models. It has like every open source model that is available on the internet is available here. You can search for models here, but you would see that for llama.cpp, we use what is called a GGUF model. These are special kind of models that are much smaller in size than the actual models. So for example, if we see, let's check some model here. Okay, it doesn't specify the size, so let's try Llama, for example. Okay, so Llama here says the model size is 8 billion. Usually, if you want to know the size of the model when we host it, how much memory it takes, we multiply the number of parameters by 2. So this model would take around 16 gigabytes of VRAM when using normal frameworks. But on Olama or on llama.cp and Olama, when we reach it, we can run it on normal RAM on CPU. So what happens is that this GGUF type of models uses about half the size of the model and the number of parameters to run the model. So for example, this is an 8 billion model. It would take around 4 gigabytes of RAM to run it as a GGUF model. So what we're saying is, to be exact, I think it's here. Okay, so usually, so we're now considering a 32 billion model. A 32 billion model on floating point 16, which is the usual case, would require 64 gigabytes of VRAM. We can use what's called the quantization, which is using less memory for each parameter. On int 8, we would use 32, which is the same size as the number of parameters. And then at int 8, we would use int 4, we would use half of the size. GGUF is a type of quantization that uses int 4 architecture, let's say. So okay, so to host our model, again, I would run this. Llama.cpp provides what's called an OpenAI compatible API, which I would talk a bit later about it. I'll show you an example too. So if I run this command in a terminal, it would start the model. Okay, so it's loading. You can see it's loaded now. It says the main server is listening on HTTP 127, which is the local host, on port 8012. So I can now use this model when I access this link. To test this, let's go here, for example. I start from 0. So for now, I want you to look what I'm writing here. Whenever I'm writing on the right on VS Code, you would see some text popping up in the terminal. For example, let's say import. So there's a suggestion to import OpenAI. This suggestion didn't come from Copilot, or I'm not using Cursor or Codium or whatever. This came from llama.cpp. So this here on the left is what generation this code completion gave me. So if I press tab now, it's here. Let's say I want to change it from OpenAI, import. Okay, again, more generations. It gave me this completion. I'll import it. So again, it's always running in the same time, trying to generate more data or more code. Okay, so let's take this for example, and then print response. So it took some text from my repo, so now it's using what's the capital of Lebanon, which you see in a bit. So that's what way we can use self-hosted LLMs. Maybe you don't want to subscribe to Cursor or Copilot or whatever. You can just use your own model, and it barely took any memory. It takes about 1 gigabyte of VRAM in my case, because I have a GPU. It's the same RAM for normal laptops, but it would be a little bit less fast. So that's it for llama.cpp. I won't go a lot more in it. Let's go now to Olama. So Olama is built on top of llama.cpp, and it's even much easier to use. So to use Olama, you just have to go to the download. You download an executable, you install it, and then you can use one of these models, one of these available models. For example, you have the DeepSeek ones. All you need to do to download a model is run this command in the terminal. For example, if you want to download the R1, this 5 gigabyte version, you would run Olama run deepseek-R1. It would download actually this one. If you want, for example, to download the 1.5 billion, you just need to Olama run deepseek-R1, come off 1.5 billion. So in my case, let me stop this one. Okay, clear it, and then think it's open. It's not open. So I need to run it. So now it's running in the background. We can see it here. It's running here in the background. I can then call Olama. So I have these models. I have Gamma 3, Gamma 3N. I have this. I will present it now. I have DeepSeek, and this is an embedding model called BGE large. So if I want to run a model, let's say Gamma 3, I will say Olama run Gamma 3 latest. This would run the model. I can now talk to it. It would text me. So, but this is very impractical. We don't have any sessions. We don't have any history. I can't use it in code. So what we actually use, the more practical, is Olama Serve. Now, whenever you run Olama, like the executable, it will automatically run the Olama Serve command. So it's already binded. For now, I would like to present to you what's called OpenWeb UI. This is also a community project that allows us to use self-hosted models to run a ChatGPT-like website. So if I go here, it's already running on my setup. So I would just access it here. Should load up. Okay, so it's loaded now. Here we can see we can add our hosting options. So for example, I already added Olama, which runs on 11,434. I just need to activate it. I will deactivate this. We'll come to this in a bit. Okay, I'll deactivate this one and then save. Okay, I'll refresh. So now we can see the models that I had in Olama list. So BGE large, DeepSeek, the OCR1, Gamma 3N, Gamma 3 latest. So let's select Gamma 3, for example, give me ideas. So it's generating in real time. Again, this is using Olama. Unfortunately, I can't see the results here, so let me do one thing. Let's close this and then run it in a terminal. So here we'd be able to see the actual generation. Okay, so it's available now. Let's do this again. And then explore options trading, I guess. Okay, so it should pop up here that we call the chat API. So it's generating. Okay, so this is it. It's called the chat. Okay, one thing to mention, like this web UI, Open Web UI, would then call the model to generate this title for the session, and then call it again to generate these follow-ups. So these are also generated by the model. We can see it here. Like I did one call to the model and it did 4. I would explore this in a bit too in VLLM. It would be much clearer. So you can also use, I think this is, so I want to also present to you this model called Nano OCR. This is actually a very interesting model. This model is very good, very, very, very good for OCR. So I will use it to, let's say, upload this. And then I want to, this is a picture of an invoice. This is it. I want the model to replicate it. So it's, try to draw it again using Markdown language. So I'll say just replicate what you see. It shouldn't take long. Okay. It actually uses Markdown and HTML. So we won't be able to see the table here, but if I copy it to VS Code, and then let's use it here. This is the output. So, okay, so didn't do it well this time. We can try it again. Okay. So because because the table is empty, it is bugging out a little bit. Try again. Copy it and replace it again. So this is it. If you would like to compare them, so this is the invoice and this is the generation. So your company name, street address, that with them all, and the table. It is empty, but it can actually fill it out when there's actual data.
Guys, we will fix this issue in a sec and we will repeat hopefully. Please stay patient. Thank you so much.
Hello, Haytham. Sorry to interrupt, but the attendees can't hear you and neither can. Yes, Haytham, can you hear me?
Okay, hello.
Yes, we can hear you.
Oh my god. Okay, my bad. Where did it stop? So, with my code. So it was here. Okay, my bad. No problem.
Could you please zoom in as well?
Is this good now?
No worries, no worries.
So is this visible?
Yes, this is good, yes.
Okay. So what I was saying here is that we've used Olama on a ChatGPT-like interface, but
now we want to use it in code. So I've said before that llama.cpp and Olama use what's called or provide what's called an OpenAI compatible server. What it does is, so because a lot of us already use OpenAI API, we don't want to change the code a lot. So they did what's called an OpenAI compatible server, which allows us to change the URL we are using for our locally hosted model. So for example, here I'm using the Olama endpoint. I would change the base URL to my endpoint, to my model, and then provide an API key. It could be a dummy, or I could set it up in the server. We should provide a dummy key here, at least like anything, because otherwise it would give us an error. So let's say we used ChatGPT before. We wouldn't have any of this. We would have here, we would have model equal, for example, GPT 4.1. And then we would call the OpenAI servers. But now we're not using OpenAI anymore. We are using our own model. So we would take this out. We would replace it with our endpoint, with our server, and then the name of our model. So I did this code for both VLLM and Olama. You can do it also for llama.cpp and SGLang and any other framework you're using. So in this case, if I run it, it's going to run on the Olama server. It's going to use Gamma 3 latest, and then it would return the output. So if we run it again, then provide an error, so it gave me an API, so it gave me an error. It should return shortly. So the capital of Lebanon is Beirut. It's vibrant, historically significant city. Okay, nice Olama. So that's how we can use it in code. Now, I also wrote another code for structured output. It's something you can find in OpenAI, in an Anthropic, in any model provider. And what it does is you force the model to return a result similar to the schema you give it. It seems that because I have the latest version of OpenAI, it's not working anymore, but it should have worked. I can think it should run properly on VLLM. Okay, so I will show it in a bit. So that's it for Olama. Now we want to go for the production grade options frameworks. So we have VLLM. It is a project started by US Berkeley University. From their testing, from their own testing at the time, it is said to have 24 times faster inference than Hugging Face transformers client, and about 3 to 4 times faster than the TGI, which is also provided by Hugging Face. It is an inference server. So what's different about VLLM is that it enables us to use multiple GPUs. However, we are forced to use GPUs in this case. We can't use the CPU. We can also use multiple machines. So we can have a cluster. We can have multiple machines running at the same time to run our models. Sometimes we host the same model multiple times just to have multiple or even more requests, serve multiple requests and multiple users. And we can serve, as I said, multiple users. On the other hand, Olama and Llama.cpp are just for a single user. So they're just only for you. You can't host it for your friends to use it at the same time you are using it. Only one user can access it at a time. Also, VLLM scales very well with GPUs. So the better GPU you have, the much faster inference you will have. So again, it has an OpenAI compatible server. I think they actually came up with the idea. But it is a bit harder, or not like in the base case, it would have a simple way to serve, but then actually fine-tuning the parameters is hard. So serving is also easy in its most basic form, VLLM serve, and then the name of the model, and then comes the parameters. So you can just use this to serve the model, it would be enough, but you should have a good GPU to serve it. Now, there are a lot of things, a lot of variables you need to use to fine-tune your model or the hosting to your... Still can't hear me? Never mind. To fine-tune this model to our GPU. We want to make the maximum out of our GPU. So what would you see here is lots and lots and lots and lots of configuration variables you can use. For example, let me show you. Here we would specify the host, the port. These are just for hosting. We can see something called tensor parallel size. So if we go to it, this enables us to use multiple GPUs. Data parallel allows us to also use multiple devices. We can add LoRa configurations. We can modify multimodal configurations. So for Olama and Llama.cpp, you can, they actually support it in the latest versions, multimodal models for image and audio, but they are very limited. In VLLM, you can go full out, but it needs a lot of configurations. So of course, I won't go into the details of these arguments. You can check them on your own. What you would see here in the README at the end is the command I'm using to run my own model. Let me run it here first. So I already used, we can't use VLLM natively on Windows. You need to use Linux. So I'm using Docker for that. So I'm using a Docker image. You would set up your cache where your models are downloaded, what port you want to use, your Hugging Face token, And then you would run the command for VLLM. Now, I don't want to go into the details a lot, but for example, I'm running a model called the Qwen 2.5 visual language. So this is a multimodal model. I'm using one GPU, float 16. How many bytes I'm using for the calculations. Trust remote code, this is something for Hugging Face. Usually there's a script with the models that comes with the models to allow us to run them. So we need to use this command. Maximum model length, if you've seen before, we have what's called context window for the models. So this specifies the context window, the maximum context window you want to use. The more you want, the harder you go on the VRAM. So I won't go into the details of these, but quantization here, also I'm using a type of quantization. It's not GGF in this case, it's called AWQ. It's also a type of quantization. So this command will run this visual language model. It's running, it's still starting up right now. It needs a couple of minutes. So here I'm going to show you a tool that I use to estimate how much VRAM I want to use depending on the requirements. So let's say we want to run the model that I'm already running now. So I'm running Qwen 5. I think I'm running the 7 billion. Okay, so it doesn't have the visual language. It's okay. We can use still the 14 billion. So I'm running it on FP16. There's something called KV cache. I won't go into it right now. It has a lot of details in it, specific technical details. So I can already see that it needs 31 gigabytes of data. So let's say we want to have about 16K context length. We want to fit in 16,000 tokens and one message. And for example, we want to serve 8 people at the same time. What you would see here is that you would need about 70 gigabytes of VRAM. It would need about 42 for the model and the activations, I'll show it here. And then it would need about 3.5 gigabytes per user. So with each user, with each concurrent user we are serving, we need extra VRAM. Now, okay, so it doesn't have generation speed for this one. Let's use another. Let's just do DeepSeek. Start DeepSeek. It's the problem here. So let's say we're running, for example, I'm running on 4070 Super. Need a model with generation speed. Okay, so we have it now. No problem. I'll go into these details a little bit. So it would also show us the generation speed, the total throughput, and then per user number of tokens. We have what's also called KV, so KV cache, how much it's using as cache, activations. So it's not just the size of the model that matters when serving multiple users. There's a lot of variables. There's also what we call framework overhead. The framework you're using also takes some VRAM. So let's say for this model, I need about 40 gigabytes. So I want to use something good. For example, we can use the 8100. It's still not sufficient. So, okay, maybe I'm not that rich. I can use, for example, the 3090. It has a lot of VRAM and it is cheap. So it was 3090 Ti. However, I still can't match the quota. So I can increase the number of GPUs. Now I have enough VRAM. And then you would see also that when you're using multiple GPUs, you have something called multi-GPU overhead. So there's a lot of details that go into this. There's also something called batch processing, how many requests you will serve at the same time. Everything takes VRAM. That's why it's very hard to maximize the performance. You need a lot of calculations. And VLLM actually can do a good benchmark for that. So for example, a 3090 Ti, for this model, I would have about 84 tokens per second. So at this time, so the model is now served. You would see here, let's see about this. So you would see here, if you read the logs, you would see everything, how it's loading, the maximum number of batch tokens, how it's filling up everything. There's something called flash attention, which speeds up the models even more. And then at the end, it would say that it is running now. So for this, again, I will use, I'll start by using OpenWebUI. Where was it? It's here. For this, I will switch from Olama to VLLM. So I'm running VLLM on port 8000. So I just need to activate this and then activate this one. It will get the models on its own. It should at least. Okay, and then open a new chat. Should refresh. OpenWebUI is sometimes a bit buggy, so. Okay, so it's open now. So you can see that, you can see it actually that it is available here. So again, we can talk to it. Hello. Should respond. And at the same time, it should be able to see the request here. So we received a request. So detected, where is it? Received request with chat template, etc. And the prompt, your helpful assistant, we didn't use any system prompt. And then our message, which is hello. You can see here how much it's taking to read the prompt and then how much tokens is generated per second. Now, this was a small example. Let's try giving it an image. So let's say I give it this one. So explain this graph. So this was from the blog of VLLM. Again, if we go here, it received the chat template, and then I told it to explain the graph. Here, where would the image be? It's just, it doesn't place it in the logs because it's too big. It uses base64 encoding. So now it read the prompt at 190 tokens per second and started generating at least at about 20 tokens per second. So here you have a lot of, or much more logs. So here's the output. It's explaining the graph. So okay, so I think that's it. And so one thing, so we've seen the KV cache. KV cache is used to cache the tokens you generate so that you would use them later and get even faster generations. So for this one, it took about a few seconds to generate, even though it was small. So we go back here. It took around, actually not much, 2 seconds, but usually it would take around, like the first time it would take about 20 seconds to load everything up, and then consequently it would just go much faster. So if we use the same, okay, let's see what we, so we gave it the image. It took around 30 or 40 seconds, 30 seconds to finish the completion. Let's see how much it would take now. Now it would still take the chat, the image in the history. So let's say what color is got? Ask it something about the image too. Okay, so you see it quickly generates. So Hugging Face is red, DJI is orange, and VLLM is. It quickly generated it within a few seconds because it has already cached some data. So if we see here, prefix cache hit rate is about 50%. 50% of the request was already processed, so it only processed the other half. That's also used in OpenAI, and you can see it in, so if we search here, actually, caching. It's called caching. So that's it. You can read about it more. It is used in OpenAI and Anthropic and others. Lastly, I just want to mention SGLang. Again, SGLang was used by XI to host their Grok model. It is built upon VLLM. It came out a bit later. It promises about 2 to 3 times faster generation than VLLM. However, I couldn't run it on my own device. I had some technical issues. But the question is it actually better than VLLM? The question is, it depends on the use case. So let's go back to the slides. I already wrote it here. So what SGLang is better is when you're using it as a chatbot or using it as an agent. It has actually better performance than VLLM and generation speed. However, VLLM is better when mostly better when we're using a lot of calls that have the same prefix. So, for example, if you're using a prompt to generate new data, if you're doing batch processing for some data, then VLLM is better. SGLang also provides a front-end API, meaning it's like something like LangChain and LambIndex. It goes well with their backend, so it's also a tool you can use. So that's it for model serving. Thank you. And you can connect to me with on LinkedIn or through email. And if you want the material, I already uploaded it to GitHub on this link, the presentation and all the commands I used. And that's it. Thank you. I'm ready for any questions. Okay, wait, I forgot something. Okay, so this structured output, let's use VLLM. It's already hosted. Okay, I use it now. Okay, so this is the output. I have the schema as brand, model, car type. So brand, model, car type. And then the car type is SUV because it is limited to one of these options. So if you see, this is the actual schema. I'm telling it that the car type should be one of these four. And if it's not one of them, it will give me an error. So yeah, and now I'm done. Any questions? No.
Hello everyone. We'll be starting in a few minutes till more of you join. Okay, seems like everyone went on a break and never came back. All right, so hello everyone. Thanks for joining once again. So first of all, you can ask any questions related to the project here, okay? Let's start. So, what do you think? Do you think that my presentation actually has 80 slides this time? Let's see what you guys think in the chat box. This meme hits again. All right, some people are saying, 78 memes. Yeah, that could be. That could be, yeah. Okay, so apparently everyone is saying no. Any other answers? Okay, someone thinks that it actually has 78 slides. Cool. So, well, let's see about that. All right. Before diving into the continuation of yesterday's session, which was about prompt engineering, let us do a quick recap about where are we right now. You saw 80. Yeah, it could be 80 slides. We'll find out together, actually. So basically, in yesterday's session, we dove into prompt engineering, a very brief introduction, and we also were discussing some of the concepts that you guys encountered during the bootcamp. No more than 10 slides, please. We'll see about that, Sarah. Tariq is saying that I've seen 150 slides. Okay, well, we'll find out, Tariq. Who knows, maybe in the next session I can make 200 slides. We'll see. So we did a quick recap. Some of you are asking which theme can you guys participate in. So just to make it clearer for all of you, you will basically choose a theme you would like to compete in as an entire team. For example, group 4, you chose the LLM engineering theme. You will compete in that theme. All right? And in case there weren't anyone, let's say, in that theme competing alongside you, all right, then you will be graded based on a certain metric. All right. So as mentioned, each theme has certain point systems, certain metrics, stuff like that. So don't worry, we will make everything clear and we will share a detailed PDF containing all of the instructions needed and everything. Please make sure to read it because apparently some of you hate reading and they keep on asking the same questions and blowing up my phone. Anyways, this is regarding the theme and stuff like that. And even if you selected a theme to start with, you did not want to compete in that, you can switch to another theme. But yes, you can use more than just one theme in your project, but you will have to choose only one final theme you want to compete in. So let me rephrase it. You chose data science theme, for example, or machine learning theme, let's say. You use machine learning, you use data science, you are free to choose in your project, you use those, but you are free to choose which theme you want to compete in as a group, all right? Not individually, all right? Now, regarding the groups, we actually have around 30 groups now, I believe, around 30. Unfortunately, we cannot accommodate people working alone. So you have to be at least 4 and at most 6 people in the team. All right? This is just a quick recap. Some of you have been very active, actually. Really impressive. They've been doing meetings, talking to one another, just agreeing on the entire flow. And actually, you started working on your project, some of you, but the others are lazy. Either they aren't replying and ghosting their team members, which is, of course, not acceptable, or they just not doing anything. So you won't be getting any point, and you might be removed from that group, and instead a new team member would be added. All right? Now, a shout out to group 5. I hope they are attending the stream right now. So this is group 5 right now. They are thriving because they already completed the first stage of their project. Those guys are really productive. I'm betting that they're all coffee addicts. So this is them. So shout out to group number 5. They are thriving. Now, moving on. So we talked in the previous session about the anatomy of a prompt. Yeah, that was boring because most of you here just basically abuse GPT and like any LLM you're using and expect a reply from GPT or something. All of you do that, which is not right, obviously. You need to abide by a certain anatomy of a prompt, stuff like that. We'll see in the examples in a few. We also talked about what do you have to avoid when prompting. So I'm betting that the nerds joining us in this stream today aren't very happy because they always tend to overcomplicate stuff and just talking in gibberish, actually. So definitely don't let any nerdy team member do the prompting part. All right. Hassan is asking why. I'm not sure what do you mean, Hassan. Please specify your question. Noor is mentioning, but what project topic do we choose? You are free to choose any topic, Noor. We're not micromanaging you guys or anything. You are free to choose any topic that you'd like to work on, but you just have to select a theme, all right? Okay, so apparently Group 5 are joining us today. Amazing work. Great. Anyways, moving on. Psych, actually, because yeah, the presentation is not actually 78 slides. Who can guess how many slides do I have? Just wait 30 seconds. Okay, someone is saying 20. All right. About group 5, I didn't hear. 80. Okay, Blob is saying 80. Yeah, makes sense. 5, 50. All right, who else? Maybe you will win a prize alongside the winners of today's. We will be announcing them, obviously, at the end of this session. Okay. And we'll be sharing it on the group as well. 80. Any further questions, answers, guys? $80, 18.5. How does that work, Amina? Okay, cool. Actually, all of your answers are wrong. It's actually only 9 slides. We'll be moving into the demo part of this session right now. Okay. So for the demo, now I know most of you are beginners. You probably haven't dealt with Open AI API before, or maybe Llama 3, any other model, or maybe Mistral. There are plenty out there, and even most of them are like quite expensive and they're costly and stuff. But like Mistral is free. I believe you get 50 or something, I'm not sure, but there are plenty of free tier options. What are we scoring? Ahmad, you must have joined late. We are scoring how many slides does the presentation have? So actually, those are all empty slides. So you fall a prank once again of one of my memes. Someone is saying that they guessed it right. Let me see. Imagine it ends on this slide. Yes, that is correct. It does end in this slide. But we're not gonna be actually ending the session here. Okay. We're gonna be going to basically you're gonna be viewing my other screen. Let me just share that in a sec. We'll be opening the VS Code, and then after that we'll be announcing the winners for the mini graph challenge and for the SDLC challenge. All right, so let me just share my screen with you guys. All right. Okay, I believe you guys are able to see my screen now. So I'll be sending all of the details, but okay, I couldn't leave you guys without a meme even on the website. So do you think I should add a meme on the website now? To meme or not meme? That is the question. What do you think, guys? Well, no, actually. This is just sort of a simple guide and to show you actual examples. There will be also the code. I'm gonna go over it at the end of this session, so don't worry about that. Let us just finish that, okay? And then I'll answer all of your questions and go over the code with you guys. I believe you are able to see my screen. Please confirm if you do. Let me just double check that. Okay. Yes, Tariq, I do like stickers. If we add memes in our project, do we win? Well, you're gonna have to try to find that. Yeah. Memes are cool. Feel free to add them in your presentation pitch and stuff. Okay? Okay, so yes, I believe you can all see my screen, which is cool. All right. Now, basically, what you can see is a complete guide into prompt engineering. There are further strategies other than that, and you can even use some psychology tricks, as I've mentioned. Okay, there are several techniques. There are even some advanced strategies. Usually when you're dealing with the API, sort of how I basically did those and stuff, you will find everything in the code once I'm done. You can notice that most of people use those. So basically only the people with advanced background, because I'm pretty sure that no one that uses, let's say, ChatGPT from using ChatGPT from the GUI or something would be familiar with those. Regardless, if you're familiar with some of those, or maybe you've been actually using them without actually knowing, then that would be really cool. All right. So what we have over here is, this is a website. You will have access to that as well. And what we have here is the following. Let's start with this one. All right. So believe it or not, actually psychology integrates with you while you're writing prompts or stuff. This is why, well, I'm not gonna say it's generalized, but most people that are book nerds, or they read a lot, stuff like that, write good prompts, okay? Or even philosophical people, all right? Because they know how to talk to LLMs and stuff. That's not the norm, that's not the usual case, but I'm gonna say around 70% from what I've seen actually. So there's actually something called psychology of prompting, and let's talk a bit about that. And what do I mean by psychology of prompting? It's basically how you can trick the AI to be smarter, faster, and basically just better. All right. So yes, believe it or not, you can actually do that. All right. So first up, what do we have? We have role psychology. All right. And in role psychology, this is when you're basically giving the AI a role. Like, for example, act as a teacher or something, something like that. All right. So some of you even might have heard about this or maybe tried it. For example, act like my strict professor, or act like my best friend or something. Act like a famous CEO or something. All right. So yeah, a lot of people do that, also known as role playing. Okay. You try to play around the rules. Okay. Okay, guys, just give me 1 sec till I fix my mic a bit because some of you are struggling to hear. Can you please confirm that you can hear me? Okay. I think it's better now. Yes, okay, cool, great. So, or maybe you can ask them to act like Sherlock Holmes, for example. Or maybe like a funny person and maybe generate a meme I could add on my pitch for this competition. Who knows, you could try that out. So you're basically just helping it in sticking to a certain type of personality. Okay? Like maybe a nerdish person, anyone. So like you're just basically telling it, please act like this personality and stick to that personality. Okay? And when you do that, it actually generates more accurate results. All right? In your specific context. Of course, you have to be specific, and you also have to know the use case. Like, you can't be, for example, writing an English essay, for example, and asking GPT to act like your math teacher, like a strict math teacher or something. Obviously, that doesn't work. So, yeah, you need to be also very careful and specific with that. All right. Next up, we have specificity effect. I've been talking about that. You have to be really specific because the clearer you are, the less confusion there's gonna be, and there will be on point answers and more creative answers as well. All right. Now, we also have something such as negative bias. And what do I mean by that? Us humans, especially bossy members like Hussein here, I believe he is with us. Yeah. So, of course, I'm just joking, but people tend to, and it's actually a known concept in psychology. There's plenty of papers about that, plenty of books if you haven't read about that. So, as humans, we tend to focus on what not to do. Okay? But AI basically listens better when we exactly tell it what to do. So, for example, when you're leading a team or something, you'll be like, please don't do that, stuff like that. Okay, this is how we humans function, all right? But if you're gonna be like, hey, yo, AI, listen, I want you to do this, I want you to not do this, stuff like that. Like, okay, what I'm gonna do it. All right, so you need to tell it exactly what you want it to do, because it listens better when you're telling it exactly what you want it to do. So you have to frame things in a positive way. So you need to avoid being negative, bossy, or even just including negative bias in your prompt. All right? Now, next up, we have something called context dependency. I talked a bit about that. So it's basically giving the AI its morning coffee. All right, what do I mean by that? So you basically wake up all those memory links and it will give you better and smarter answers if you're being very specific. All right, so this is really important. Now, moving on, I think some of you might have heard about it. Maybe you've probably seen posts about it. It's called COT, chain of thought. So, when we're trying to solve a problem, what are we usually doing? We're basically thinking out loud. Maybe some of you maybe like to brainstorm on a paper, something like that. So we tend to, think out loud, okay? And AI loves that too. So if you break tasks into steps, the AI will basically follow along and it will solve problems more accurately. By the way, this is actually a problem solving technique. If you're into the psychology field or something, you must have noticed that a lot of people tend to do that. And even us developers, we have that problem solving skills and we tend to break stuff down. All right. So this is a common interview question, by the way. One encountered with a problem, behavioral question, actually. We're exposing the HR secrets out here. Anyways, they tend to ask this a lot. You have a certain problem, etc., and how would you solve that? So the golden answer here is I break it down into small chunks and stuff. Of course, you have to elaborate further on that. Anyways, back to our topic. So you can think of it the same way as we're writing a prompt. We break things down and basically into digestible steps so that the AI can follow along. All right. Now, moving on, we have another method. We're going to be going over some examples, by the way. So promise I'm not boring you guys. We have something called the few-shot learning. So essentially what few-shot learning is basically showing examples. There is zero shot, there is one shot, there is multi-shot. So it's basically showing the LLM examples, all right? And the AI would be learning by examples, just like us humans do. So usually when you're solving a mathematical problem, you check the example, how did they solve it, stuff like that, and you practice on that. So the more examples you have, the better basically results you will get. Of course, that tends to break down at a certain extent. So like, don't abuse ChatGPT or whatever LLM you're working with several examples. All right. So just give it a few and it will start to catch them. So basically, if you want great results, all right, make sure to abide by those. Like those are extremely important, okay? And literally very few people tend to not use them. Feel free to drop in the chat box which method of those have you guys been using earlier to hearing about it in this workshop, let's say. Now, moving on, as you can see, we've talked about how prompts have to be clear with instructions. So, for example, okay, to abide by being clear and having clear instructions, let's say you're texting your friend. I mentioned that example yesterday. So, basically, you have to be clear with your message because you're communicating. You're not just sending a message, you're communicating, okay? Try to think of it sort of in the same way. So here, as we can see, how to create a villain. Like, what the hell is this question? It's not even clear. So a better way to phrase that prompt would be create a step-by-step guide. Notice how we gave it instructions and we were clear for designing a compelling villain for a fantasy RPG. Okay? So we specified like what do we want the villain to be for? Include 5 specific steps with examples from existing games, etc., etc. And we even specified how many words that we need. Okay, I'm gonna pause just a bit to see if some of you typed anything in the chat box. Okay, seems like everyone is asleep. Cool. Do we add another meme? Okay, seems like the people here need another meme. We'll see what we can do about that. Okay, so this is how you ensure you're abiding by being clear and stuff. And the role play thing that we've talked about, as you can see, this is how you ask it to be a character role. It has several types. It's just basically adapting on that persona. You even have an expert role. By the way, this is amazing if you're doing research. If you're researching about anything, this is extremely amazing. Act like you're a game theory professor, something like that. So it's extremely great. All right. Now, let me show you an example. By the way, those prompts, I tried them and you can go ahead and try them as well. You can try them in the code. I'll go over the code in a bit. We also have the negative versus the positive. We've already talked about that. Don't be too technical. Don't use jargon. Don't make it boring. It wouldn't give you good results if you're always negative. So be positive. As you can see, we can turn those into some positive stuff. It basically gives us clearer direction, no confusion, and it actually focuses on the way that you want the outcome to be. Okay, so don't be a bossy person when you're typing a prompt. This is another example on the context and detail level. Okay, this is minimal context. You need to provide rich context. For example, notice how all of that is just describing the context. Okay? Now, we also have prompt formatting, as you can see. So this is actually often slept on, even though it's extremely important. You can actually format your prompt. How can we do that? You can add clear sections, bullet points, numbered numbered lists. Like the more structured it is, the better the answer. And you can use hashtags and stuff like that. So this one is actually extremely important because you are basically keeping the answers clean and organized, and it's easier to read and basically more consistent. Okay? And this is an example on how you do the chain of thought, the COT. Okay? This is more into reasoning and stuff. Now, it's a bit an advanced topic, so we won't be covering it during this bootcamp, but I'm pretty sure you've heard about reasoning agents, stuff like that. So it's extremely used. There, as you can see, this is an example of COT. And this is another example of few shot. By the way, I'm going to be sending the website for those of everything will be basically sent for those of you asking, does it work better if you're rude? I don't know if I should answer that. Maybe OpenAI will ban me because I keep on abusing it with being rude. Jokes aside. Personally, I tend to notice that, yeah, it tends to give better results when you're rude only if you specify exactly what you want. So I'm gonna be saying it's sort of a mix of being negative and positive. But all of the guides out there and the big LLM models and stuff always recommend that you're positive and not negative. Personally, what works for me is having a mix of both. But of course, start with being positive first, and then, as mentioned, it's not a static. It's you're constantly tweaking and stuff. So first, write the prompt being all positive and stuff, and then who knows, maybe abuse it and tell it, I'll go and use DeepSeek if you were using ChatGPT, for example. So this is just another way of doing things. Personally, I do that, and it works every time. Seems like ChatGPT gets scared when you're threatening it. Now, next up, we have a few short prompting. As you can see, we're providing an example. We also have testing and analysis, and we have advanced strategies. Now, regarding the advanced strategies, as you can see, you're just basically progressively building the context and not at once. And it's really great. But it is more sophisticated, but you can try that out. So that takes us to the end of that little demo. I'm gonna be going over the code with you all, and it will be provided and everything. Now I'm gonna suggest that you guys try Mistral. You can get up to 50 API keys, I recall, and the free tier is just extremely generous. But before I wrap up, this is basically the clear framework that most people, while doing prompt engineering, usually follow. So you have to provide context. You have to basically provide length. The length has to be specified, include examples. Here we're talking about few shot, multi-shot, etc. And even specify the target audience and the expertise level. And also you have to role play properly, okay? So you will be using the Python 3, which is the demo.py file for interactive examples in the code, and Python 3 made for API for live testing. But once again, get your own API key and run the code. Okay, let me share my screen and let's just move to the code. Just a sec. Give me a few sec. Meanwhile, guys, feel free to drop in your questions. Okay, can you guys see my screen now? Okay, seems like no one has any questions. Can you please guys confirm if you can see my screen? Okay, let me try one more thing. Just a sec then. Just one sec. Okay, can you guys see my screen now? I believe it should be clear. Okay, let me just double check. Okay, cool. Great. Okay, so this code will be provided and posted and everything. But I have to tell you, it's a bit advanced. Don't worry about that. But I will be providing proper documentation. It's fully documented with a README file. I'll be adding it to a GitHub repo and all. And this is the demo website that you were looking at. And this is the, let me find that. This is the meme actually. So like it's entirely clear. I provided in the README file which of those you have to run. So what I want from you guys is to go to Mistral, sign up. It takes 5 minutes, by the way. So basically, you have to sign up, create an account, and get a key, and then add that key. I will be specifying in the README and everything. Regarding the code, for those of you with advanced background, I believe you won't struggle. But for those of you that are not familiar, no problem. We will be having a very detailed session about how to deal with LLM APIs, stuff like that. We won't be using OpenAI. Personally, I maxed out all of my Mistral free tier credits, so I won't be able to demonstrate that, but I did generate those using OpenAI. You can change that obviously and choose to work with Mistral instead. It's just basically changing a few things, and I will definitely be updating the code to suit both ways, but I'm pretty sure no one wants to use a OpenAI. I'd like to note that you can actually download their desktop application and they would give you five. I'm not sure if the offer is still on. I guess that was a week ago. And they will basically give you $5 credit or something like that. So maybe do try that out and check that out. I will be taking questions if you has any questions, and then we will be announcing the winners. Okay. Yes, I will be sending everything, the code and all. If there's any questions, please feel free to type them in the chat box. All I can see is yes and yep and stuff like that. So I'll wait 30 seconds to see if there is some answers. If not, then we're gonna move to announcing the winners. No one has any questions related to the project. That's weird. So you just guys tag me on WhatsApp and get real shy when asking here. Should the report include the actual code we used or just an explanation of the steps? Okay, yes, we will be adding drum rolls. Let me see. Okay, Hanin is mentioning, should the report include Hanin, what report? Is it necessary to prepare a PowerPoint presentation? Yes. Yes, it is necessary. How much time you have? You basically have 5 minutes for each pitch. Okay, so maybe choose the best person with public speaking skills before working on it. Maybe someone works on the PPT, the other works on presenting it and stuff like that. But we will be asking questions to the entire team. Okay. Okay. Is it necessary to prepare? How much time do we have to? I asked you before what is the difference between prompt and so basically in prompt engineering you're basically trying to engineer the prompt in a certain way to get a certain outcome. When you're talking about context engineering, you will basically be Okay, can you guys hear me? Not sure if I got disconnected. Okay, anyways, basically when you're writing a prompt, you're just formatting that prompt or writing that prompt in a way to get a certain outcome from the LLM and such, okay? So you're just basically prompt engineering that prompt in a way to get what you want. Regarding context engineering, you can think about it like how you're managing what your the LLM that you're using. So like you need to provide context at like any point. We talked a bit about that example. So the model has to know like what's the context, for example. So you can think of it as part of prompt engineering, but it's like basically providing more context. For example, let me give you one example. Let's say you're working on your research, okay? Or basically you're working on an assignment or something. I'm pretty sure that all of you here are talkative and you like to spam your professors and such. So you usually need to know about certain context, how should I do that, stuff like that. So it's basically just giving the LLM via the prompt context, okay, so it could have like better results, okay. And by the way, ever since OpenAI updated their ChatGPT and stuff like that, ever since they released the latest update, it can remember stuff from the memory and stuff like that. So history, your history, like as a user, is actual context, by the way. Okay, so you can think of them like the same thing, like something is part of another thing. Okay. Should we submit the project as a code or a website? Ala, were you attending the previous session on GitHub? Yes, yeah. Yeah, definitely. This is a cool fact. Ala, we went over that. We mentioned you will submit everything on GitHub. And Hassan showed you how. We will be sending a detailed guide as well for some of you that attend without listening, obviously. So we will be sending that. Let me see. I hope I didn't get disconnected. Okay, so we will be sending like all the details, but you have to submit it on GitHub. And we went over that, by the way. We mentioned that you have two parts, the AI part and the model part. So just submit the code. We're not asking anyone to deploy anything on a website, stuff like that. You can just run it locally, okay, and provide maybe a screenshot or a video or something. We do not encourage screenshots though, because you will obviously be manipulating it to match what you want, obviously, and just adding screenshots. Don't worry, we'll be checking the code fully, okay? So we have to submit a report and the PPT and push the code on GitHub for the final submission. Yes, you will be pushing the code on GitHub. Regarding the PPT, obviously, regarding the report, you can choose to make a clear README file. No need to add a report, okay? No need for that. But we will be taking information from each member and such. Okay, so I believe we have no further questions. Let me actually announce the winners. Guys, so are you ready? Do we announce the winners now? Drum rolls, please. Okay, seems like no one is excited. So do we announce the winners or do we keep on answering your boring questions? Joke. Okay, I'm gonna be sharing my screen just a bit, Hassan. Okay, just a sec, guys. Please confirm if you can see my screen. So the winners for the graph competition are the following. Okay, so there were extremely great answers and great examples. Those are basically the winners. Now, the reason I went with 5 people is because there were plenty of good answers actually. So, congratulations to everyone that won in the graph competition. Okay, and because all of you were really excited and the graph field is extremely new, we have like around 4 or 5 people overall in Lebanon that actually know shit about graphs and stuff. I will be offering a one-on-one session to everyone that participated in the competition and submitted via the form. Okay, so congratulations to all of you. Well done, great jobs and stuff. Okay. Now, regarding the other competition, the STLC, we have Hanin Khalil. Okay, she won in the STLC competition. Congratulations, Hanin. Your answer was well thought and clearly detailed and stuff like that. Okay, so once again, congratulations, guys. Amazing work. The answers were really cool, really great, and congratulations on winning the competition. And even the code was really well written as well. So, congratulations, guys. And with that, we reach the end of today's session. I hope that you guys enjoyed. I will be sending the code and everything. Of course, we will be contacting all of you, so stay tuned for that. Regarding the rest of the people that participated in the graph competition, I will be sending a Calendly invite for your one-on-one session. Okay, once we are completed with the bootcamp and stuff, maybe within 2 weeks, because we definitely need a break. Personally, me and Hassan. Anyways, congratulations, guys. Well done. And with that, we reach the end of the session. If you guys have any further questions, please make sure to ask. Yeah, not really 13 slides, but yeah. But can I ask, based on what did the graph win? Okay, so basically the use case, okay, the overall LinkedIn caption and the description, and the submission that they have submitted in the form that I shared. So there was several factors taken into consideration and criteria as well. No. The point wasn't to make the graphs and data bigger. Definitely, we're not taking that as a criteria. It's overall the work and everything, okay? So it's basically the idea itself, okay? How did you structure it, stuff like that, and how did you present it, and the code as well. All right? So, with that, we reach the end. If you guys have any further questions, please feel free to ask. If not, then I believe we will be closing the stream in few. I'll wait 30 seconds. Not related to the amount of data that you use, not related to the graphs. Okay? Okay, then I believe no further questions. Okay, good luck to everyone participating in the project and all. We will be reaching out to you with further details. Have a great evening, everyone, and I hope you enjoy your start of the week tomorrow. We'll see you soon. The schedule will be announced for tomorrow in a few.